Greetings everyone. Welcome to lesson 2 of trigonometry for students and surveyors. We'll pick up and review a little bit of what we did yesterday, a fair bit just to get you going on that. And in watching my own video yesterday, I noticed that I had a lot of the, when I showed you some of the materials, it was off camera, it was too low. So let me just start with going over that stuff. Very first thing is I'm going to show you this. The HP 42, let's see, where is that at? There it is. And the HP 42 is the program that you can download for free on either the iPhone or the, what's the other one? Samsung. Yeah, so there you go there. Wanted to show you. So it's RPN. You can, I don't know if you can switch this one to algebraic. On mine you can, on the 35s. I use RPN, I like it. I think you'll like it too. This is the 2 this is the 35. Show you a few things here that I didn't quite get to yesterday. Okay, so there we can see it there.
Now you've got to go up a tiny bit. Right there.
All right, there we go. So we're going to enter a number, 45, enter. Let me just get out of here. Let's get out of here. And these are your registers here. That's called, those are registers. So you want to store a number, let's just say 40, and you want to go store. And now you just pick where you want to store it. So we're going to go store 1. Then you got to hit enter to do it. That's where it's different than the other ones. Then you want to go, let's say 20, and you want to go store plus 1, and then enter. Okay, so now we want to check that. We want to recall 1, enter, and there's 60. That's how you do that. That's how you store it. If you store it without going plus, you're just going to overwrite what's ever in there. So if I just went 30, store 1, and enter, then recalled 1, enter, then I'm going to get 30. It overwrites what's in there. So if you don't hit plus or minus, whatever it is, whatever the function you're trying to do, it'll just overwrite it. When we're doing traverses, we're doing multiple angles on one on top of another, maybe 5, 6, 7, 8 angles. We'll use this feature a lot. We'll write down an angle, convert it to decimal degrees, and then we will store it. Oh, I don't have my earplugs on. Then we'll store it. So I'll put those on a little bit. We'll hear it a little bit better. And then we'll store it, and then we'll add them all up. So there's that. And I'll put my earplugs on in a minute. The other thing is when we do a number 45.2356, we're going to need to convert hours, minutes, seconds to decimal degrees. Your conversion is here and there. Orange key, convert is right over the 5. Then you got 2 directions, HMS or HR. So we'll say that 45.2356 is the real degrees. We'll change it to decimal degrees. And there it is right there, 45.3989. Now, if you're doing a traverse something, you'd want to store that. So we could go store, we'll go 2, enter. Now, you always want to check that you did it right. Recall 2, enter. There you are. So that's how you run those, and you'll have to practice yourself. And that's all for now. Let me just put my earplugs in so you can hear me better. And thank you, Pauline, for letting me use your phone.
You're welcome.
This will go in right away.
Earbuds.
Earbuds. Oops. There we go. Bet you can hear me now better. On the HP 35S, when you hit store, here we'll just go 12, store is blue shift. Now when you do that, you'll see A to Z up there. What that does is that activates the alpha keys.
Just a tiny bit there.
That activates the alpha keys up here. So you have blue, store. Let's see, let's just start over again. We'll go 12, and we're going to store that. Blue shift key, store. Now that activates the alpha keys. If you look at the little tiny orange alphabet numbers under the keys, you can store A, B, C, D, all the way up to Z, or you can store it anywhere else you want. So I'll just store this one as 1. Store 1. Now this one I don't have. Let's just try to recall 1. Oh, okay. 12. Store 1. Okay. Now I can go 36, enter 56, plus. That's all nice. But now I just want to recall that first one. Recall 1 is 12 plus. There's my answer. So that's how that works. You don't have to. That saves the thing. And then here you go back and forth from hours, minutes, seconds to decimal degrees that way. And that's that. So when you get these with the 35S, you get a manual and a disk. So you can load this up into your calculator or your laptop or whatever you want to load it up into. You can also download the HP 35S manual on your computer. And for the HP 33S, which I showed you yesterday, they send you a bit. So they don't make these anymore. But as you can see, these are pretty comprehensive calculators. They do a lot of stuff. All right. What did we do yesterday? I want to finish up. There's something else I think. Yes. When I did the protractor, I wasn't. Yeah, here it is. I was out of screen, was off screen, I was too low. This is one type of protractor. It has this little visual doodad so you can see. Okay, let's see if that opens up. So on and so forth. You can actually set it at a number. Let's see, that's 60 degrees. That's what that looks like. This is a half protractor. They're pretty handy too. What you want when you're getting a protractor, you want to have the zero go both directions, going right or going left, whether it's a half a protractor or a full one. Keep that in mind when you're buying these. If you're getting off Amazon or wherever you happen to get them, this is just another version. Then there's the other completely round versions. So there's that. And I also showed you my tape. Base 10 is obviously the easiest way. When you're an engineer or surveyor, you're using base 10. You're using a tape that's in 1 foot increments. It's not metric. There's your, on the bottom rule scale, on the bottom scale is 12 inches. Okay, on the bottom, oh, sorry. On the bottom scale is 12 inches to a foot, so on and so forth. So just like normal. On the top, the foot is divided into tenths. The foot's divided into tenths, so it makes it easier. So you have a tenth, you have a tenth of a tenth is 100th, a tenth of 100th is 1,000th, and so on and so forth. So on and so forth. And the data collector, or on the calculator, you can we set our decimals to 4 places. That's called fixed. So you got to look on your calculator, look for where you fix it. You want 4. By the way, so when we're talking surveying, we're talking tenths or hundredths of a foot. So this is a tenth of a foot, hundredths of a foot, thousandths of a foot, 10,000ths of a foot. So 4 decimals goes all the way up to 10,000ths of a foot. If you're looking at machinists, they go to 10,000ths of an inch. So they're much finer than us, but we're fine enough that we can be within one of these ticks, one of these 100th ticks in a mile. In a mile of traverse with 6 or 7 turns. They're that accurate. It's amazingly accurate if you have all your equipment set up and working right. So this is what we use. It makes it a lot easier. The construction guys that build your houses, that build the streets, so put in the sewer stuff, everybody uses these things. We don't use inches. The architects still use inches. Okay, so that's what I meant to show you yesterday, and I think I was too low. There you are. All right, so that's an engineer's tape. Let's see, what's that called? Engineer's tape in feet and inches. And finally, in the old days, I showed you to do the angles yesterday using arc sine, arc cosine, arctangent, the arc. That, in the old days, they had their survey books, and how they figured all that. Oh, here's the other big compass. Here's the other one right there, or protractor. There's my baby. There it is. I got them all over the place. So that's a nice one too. Nice big one. Goes in both directions. All right. So this is how they used to do it. You'd see 28 degrees, and then all the sub sine, cosine, tangent for 28.1, 28.27 point. Let's see. Let's go 28.0, 28.1, so on and so forth. This is what they use. Now we hit a calculator. We go arctangent. And that converts that ratio, the two side ratios, into the angle. Just to show you, surveying was a lot different. There's exponents for external curves, for curves, a lot more math. Yeah, just a whole lot more math back in the day. So we're pretty fortunate. So what we're doing is kind of a blend of the data collectors, what I explained what data collectors do, handheld device, sometimes, and I also think I said laptop, yesterday I meant tablet or iPad type of a thing. It can also go on your staff, holds that, and that controls the gun. We call it a gun, just short for it. It's a transit. It used to be a transit. A transit is just a telescope with crosshairs, very accurate, that can 360 degrees up, down, and left, right. Full rotation on its axis, two axes. A theodolite is the same thing with measurement. Then they started calling them total stations. They did everything. And then there's robotic total stations. Then the last gun I had was a multi-station, and it was an electronic robotic total station, or not robotic total station, yeah. And it just very slick, very super accurate. Gun. And what they do is they follow, when you're walking, they follow the prism around, and they just, wherever the prism's at, it locks on it. You take your shot. Your shot is a measurement. It measures from the gun to your prism. You give it the rod height. It subtracts that rod height, and that's what your ground elevation is. That's the simplified, very simplified version. So we're measuring all day long. So that's what we're doing. And everything we do, we're using trigonometry. Whether a lot of the newer guys know that or not, but that's what we do, is trigonometry, geometry. They're the same, and so we map, and then we take maps and we make subdivisions or buildings. All right, so that covers the stuff I missed yesterday. I remember I had 3/4 for the longest time here when I was watching that. Sort of horrified me. That's supposed to be 3/5. I noticed I did correct it. And over here, let's just review a little bit of yesterday. I broke apart the triangle so you can see the components. We have sine is opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. From what perspective? From the perspective, in this case, of A. So the opposite of the angle is A, because it's not touching A in any way. It's the opposite, so that's A. The angles are indicated with a large A, with a capital A, uppercase A, and the sides are lowercase. So those correspond, AA, and then B, uppercase. The opposite of B, on this case, is the lowercase. And then, so we have the tangent. We're not going to worry about these. The tangents are just the inverse of those, or the cotangents, cosecant. The cosine is the adjacent. That's adjacent to the angle, and that's over the hypotenuse. And over, of course, means divide. So you're dividing 4 divided by 5, and you get the ratio 80. 3 divided by 4 for the tangent, you get 0.75. And then the sine is the opposite, I think the opposite, cosine tangent is the opposite over the adjacent, and the sine is the opposite over the hypotenuse. And that over here is 3 over 5, not 3 over 4 like I had. Here's what it looks like, and that's 60. So if you take the component parts, the pairs of these lines off, we're going to go with sine. That would be this symbol here. This circle here is this angle. 3 over 5. You do the division, you get 0.60. That means that this is 0.60 as long as that one. The cosine, 4 over 5, based on this, 4 over 5. And that's 80, 0.8. 0.8 as long as that one. And then the tangent is that, and then you always, the tangent, look for the right angle symbol. And if you do draw a right angle, make sure you put that little symbol in there. That shows, because if you have an 89 degrees or 91 degrees, and you're just drawing it out, somebody says, well, that's supposed to be a right angle. If you draw that in there, then we know it's a right angle. All right, so that's 75. So this line is 75, 3/4 as long as that line. And then you get the arc tangent, arc cosine, arc sine to get those angles. Now, I didn't break this one apart, so let's do that. Let's go ahead and break this one apart too. So now we're looking at it from angle B. Let me just change things up here. Now we're going to use this one. This is the perspective, no longer A. We're looking at B, B. So now we're going to go the opposite. We're going to go the tangent. We'll go B, B perspective. We'll go tangent. And remember, tangent's easy to remember because T is perpendiculars, and there's a perpendicular line, it's 90 degrees. So you can draw a little square in the T so to remember that T is your tangent. So your tangent on this one is 4 over 3 rather than 3 over 4 from this perspective. It's 4, now it's 4 over 3. So 4, 3. Okay, and then grab your little calculator. You get 4, enter, 3, divide, or you would just go 4 divided by 3. And the ratio equals 1.333, and then as I showed you yesterday, and I'll show you again, there's a show on this. Shift key orange, and the enter has show above it. You have to hold it down for a minute, and then that's just endless infinity, 3's to infinity. All right, that's your tangent. Now we're going to go, let's go cosine, and we're going to go 3 over 5. Cosine is 3 over 5. So 3, enter, 5, divide, 0.60. And then we're going to go, our sine is our opposite, 4 over 5, 4, and that's 0.80. Sine. Oops. 80. Oops. Where'd it go? On the ground. .80. There we are. And I think we already went through all those yesterday. But now that we have those, we can go 1 point. Well, we'll just go, let's just start here again. We'll go, tangent is 4 over 3. 4, enter, 3, divide, 1.333. Now we're going to go arc tangent, 531301. We did this yesterday already. So just refer back to there. Same thing with, you'll do the same thing. We'll do it real quick. Cosine, 3 over 5. Does that make sense? This is adjacent. Oh, by the way, cosine is also the other easy to recognize because it's co, and then it's connected. So this is the two lines, the two sides, where the two sides connect. That's your cosine element of your triangle. So we're going to go 3, enter, 5, divide, that's 0.60. We're going to take the arc cosine, 53/1301. And that's the decimal degrees. And now let's go with the sine. The sine is going to be the opposite. That's b, is little b, 4 over 5. 4, enter, 5, divide, that's 8. Arc sine now is 53/1301. So being able to identify, oh yeah, I didn't break that out, no. Okay, we're not done yet. So let's just go back. Okay. Let's go back and break this one out. So your tangent from B is like this. That's the tangent from B. We'll go over here. Tangent is B. We'll go, let's put it over here. So this is your 3 side, and this is the 4 side. 3, 4. That's the tangent. And this circle represents that circle. Right there. This is the vertex, the vertex of the angle. Your cosine from the B perspective looks like this. So you have 3 and 5. Cosine 3 over 5. Tangent 4 over 3. And then your sine, break that out. That's the opposite over there. So now you're looking at this figure from here. And that's your sine. And that's going to be 4, 5. So this is this triangle, exploded view, now from the B perspective, no longer the A perspective. That's the exploded view from the A perspective. That's the B perspective. And I'm stressing that a lot, that's the key to identifying the triangle so you can know which function, sine, cosine, or tangent to use. So think about that, and there you go. That's what we did yesterday. We're going to do some more today. Oh, and the one other thing is I didn't go way too long yesterday. I said I'd keep them around a half hour. I went well over an hour yesterday, but that was introductory, so we'll try to do a little better than that today. So we're going to flip this over. Let's see if I can remember where that's at. Still in there? We're in the screen real good?
Yep.
Frame in there real good. Okay. All right. Now we're going to start coming to some exercises. Set that out of the way. Here's a triangle. Now where I come up with that was with inches. That's 27 inches, but I just added the 0 to make it look like a bigger number. 270, and that's 11 inches. That's 110. I added a 0 to that one. Okay. What do we want to do now? I want to get the black magic marker here. And that's a right triangle. So the first thing we can do is go ahead and add our... Now, what depends on what angle we're going to talk about. So let's just go and stick like we did with the other one, with this one. So remember I told you about the 3, 4, 5 triangle. Use that as a template. Keep that metaphorically or virtually in your back pocket so you can always say, okay, I'm very familiar with the 3, 4, 5 triangle. I know how all those work. And hopefully you'll do a lot of homework and a lot of sketches on your graph paper using your scales and solving 3, 4, 5 triangles every which way you can think to solve them. Really challenge yourself. Then once you have that down, When you go to an odd shaped triangle, this is similar, but it's an odd shaped triangle. We're going to get to much more odder shapes. Then you'll be able to look at it and say, wait a minute, if this was the 3, 4, 5 triangle, this is how I would solve for this side because I know what the answer is supposed to be. Here it's hard to solve for it because you don't know what the answer is supposed to be. Now, we could use Pythagorean theorem, a squared, b squared, c squared. Maybe we'll do that to check, but we don't want to do that. That doesn't tell you the angle either. That tells you the side distances. But it's very useful. All right, so we're going to call this angle A. Again, just like we did. We won't vary too much today. A. So this is going to be side A. And we'll call this angle B, just like we did yesterday. And this will be side B. All right. So what we got to do is either figure out, we're going to figure out the length of this side and the angle. The length of this side we could use, like I say, Pythagorean, but we can also do it if we figure out the angle first. Now, does everybody remember how to do that? Sine, cosine, and tangent. First of all, look at that triangle, and what are you given here? Well, it looks like you're given the tangent. I'll just write them small here. Then here's your A. There's your 110, 270. That's your tangent. You're given the tangent. That's all you. So that's what you have to use. You don't have anything else. You don't have the hypotenuse, so you can't use sine. The sine is the opposite over the hypotenuse. You don't have the hypotenuse. You don't know what that is. You don't have the cosine. You have the adjacent, but you don't have the hypotenuse. So you have those two sides. So you're going to use tangent. Tangent is the opposite over the adjacent. So go ahead and solve that. What you want to do is divide those, and that gives you that ratio between, and obviously this is going to be what, 27 times longer, so 110, enter, 27, divide is, or yes, 0.4074. 0.4074 is your ratio. So we'll just go, well, we don't even write that down because it's a decimal. So what we're going to do is store that 0.4074. In fact, we're not even going to, we'll write over here. That's a ratio of those two. And then if I hit show, and you can see it goes way out there, 0.4074074074, and so on and so forth. Okay, now we want the arc tangent of that. That's the ratio. We want the arc tangent of that ratio because it's the tangent. We wouldn't want to use sine or cosine. We don't have any of those elements to work with right now. So let's go to arc tangent, and that would be blue key on this one, and arc tangent. 22/1663, and that's the decimal degree. So I'm going to store that as theta again, as 0, and store 0. Now if I had anything in 0, as I was saying before, it would have overwrote it, because I didn't say store plus 0, I just said store 0. So we have that in there now. So I'm going to write that down, 22/1663. All right, now that I have that stored, because I got a decimal and the numbers connected or contiguous, you know that it's not the angle. So now I'm going to convert it. I'll go here and convert it and go, this is the blue key, HMS 220959. And we'll write that down. 220959. All right, that's this arc tangent. There you are. Now we're going to find this length, and this is going to be a little bit trickier. Now we're going to take that angle And we're going to use that angle to find the length of that line. So we're going to go back to my recall 0, which is that number. And now we're going to say there's two ways to find that. We can use cosine, which we have, or we can use sine. The reason we can use cosine, because we have, so remember this is the cosine of this angle now. Let's go back up here. The cosine of this figure here would look like this. This is angle A, and 270 down here. We don't have this one over here yet. That's the cosine. The sine would look like this, and I'm opposite here. So the sine's going to look like this and this, and this can be 1, 1, 0. That's this side here, and of course that's the vertex of the angle of angle A. This angle, this guy right here. Now, to do that, we draw that number, and then we're going to hit, let's do it with cosine first. Cosine is 0.9261. Now notice the height, this is where probably going to make some mistakes until you get used to it, especially if you go fast. That's why you got to go slow. There's what that number is, 0.9261. What we're saying is, because I use cosine, I'll multiply 270 times 0.9261. Well, that's a number less than 1, so that means it's going to be less than that. Well, it can't be because of the hypotenuse. So you can either divide, or I'll just show you the easiest way to do that. Just hit 1x. When you're doing the hypotenuse, the longer one, just hit 1x on your calculator. That's right here, and that just inverses that number. And later on, I'll show you how to divide, but I want to do both of these at once because you might get confused. The easiest way is just hit 1x. Now we have 1.0798. Now if you hit show, 10798, 059, 0645. And now we'll hit 10798, now we'll go multiply. 23.8593. 23.8593. Let me just see if that's right. 23.8593. I don't know that that's right. I think I already checked that. I thought it was 22.2, 23.8593. One way to check it, but we'll just write it down for now. 23.8593, that'd be 230. No, that's definitely not right. Okay, so we did something wrong. Let's start over again. So we'll recall 0. We want the cosine. We want to 1x that, and 270 times 291.54. That's a better answer. So that's the other thing about math. You got to know when you're getting the wrong answer. It's not that the calculators everything is wrong. You have. So let's go 291.54. All right. So let's write that down. That makes sense. It's definitely longer. 291.54. I just rounded off there. 547. We'll just put it all in there. 5476. Okay. Now, if you have your, now we can do a squared, b squared to check that. So let's do that. 110 squared, 270 squared, plus, where you're going to go is 110 squared plus 270 squared equals, now we want the square root of that, is 291.5476. So that's really where the Pythagorean theorem is very handy. You can check your math that way. 291.5476. So we checked it with the Pythagorean theorem. Okay, so I don't know where I stumbled off that number before. I'll be talking. So we took this number that we had stored, that's the angle, the digital angle, decimal degree, sorry, the decimal degree angle that we stored. Let's just review that again. So we're going to go recall 0, 221.1663. Now we're going to use this one, the cosine. So that's the function we're going to use. So we're going to use cosine of that angle. Cosine of the angle before you enter the distance in. You're taking the cosine of the angle, so we're going to go cosine. And that gives me 0.9261. And you know, since that hypotenuse is wrong, or longer than anything else, it always is, that it's got to be a plus a 1 point something, not 0.9. So that's your clue. 1x, and that gives you the inverse is 1.0798. And now you want to go to this distance because you used the cosine function, you want to use the cosine distance. Now you want to go 270 times, or 290 or 270 times, or that number times 270 if you're using a regular algebraic calculator. And there's your answer. So now we're getting to where we can just about solve it. Well, there's another way to do it now. We also have the opposite. And we have this angle and the opposite. So let's just say we didn't have this. We don't have the 270. That's not there. We're trying to solve this distance with just our angle and just the opposite. So remember we said either two sides to solve a right triangle or one side and one angle. Okay, now we're going to go to that side. We're going to use the sign, the opposite over the hypotenuse. So we're going to pretend like we don't have that length yet. So let's just go to, we do have the angle. We have that stored. So recall 0. Now we're going to go to sine. And that's going to be 0.3773, a small number, so that's obviously not right. So we hit the 1x. Now we have 2.6504. Now we want to go 110 times 110 times is 291.5476. 291.5476. So now we've solved it from that direction. We solved it from the sine. Now you've solved it every which way there is. So we solved, now since we've done that, we gave you that distance based on just the angle and just the opposite. And then we gave you this distance based on the two sides. And I think we used cosine to start with to get that distance. We used that times cosine, inverse the number, and gave you that one there. Just do the 1x when you're doing the hypotenuse. That's the easiest way. The other way is to divide instead of multiply. And I'll work that out a little bit later. I don't want to stumble around on that right now. Oh, and by the way, this is angle C, and this is side C, lowercase. All right. Now, what do we got here? We're going to finish solving this and then call this a day. We got, remember we have a 180 degrees inside, and the inside sum of all triangles, the sum of them is inside angles, all add up to 180 degrees. So let's fill in the missing angle, and then we'll have this whole thing all solved up. So we recall, this is why you want to use memory. You don't have to keep writing it down every time, and plus you get all the extra digits that are hidden in here that you can find and show. So we'll just go hit recall 0 again. Remember, I use 0 sometimes because it reminds me of the symbol theta, which is this Greek symbol. Something like that. And that means angle, that's the angle. So we got that angle, and now we have that one. And now we're going to add that angle to 90 degrees. We know that's 90 degrees. Let's write that in. 90 degree. All right, so that angle, enter 90 plus, or that angle plus 90 degrees equals 112.1663 in decimal degrees. Now we want to go 180, for that's the total of an inside triangle, and go minus. So, and I'd take the negative sign off, 67.8337. I'm going to store that as 2. Store 2. And just so I don't forget, I'm going to store that little box here. Getting in my own way. I'll put that over here as 2. There. And do that, I'll tell you, that saves you a lot of trouble when you start running big complicated sequences of numbers and you forget where you stored what. That really helps. All right, so we've got 67, 83, 37. And that converts, and I've stored that, so that converts to 675001. Degrees, minutes, seconds, or hours, minutes, seconds. And let's go through this again. 60 seconds in the seconds. 60 minutes, 60 seconds in every minute, 60 minutes in every degree. So 3,600 seconds. There's 3,600 seconds. In one and I'm going to put an exclamation point there because that's pretty significant. And that's also why we set our decimals 4 places to account for the first 2 places are for minutes, the second 2 are for the seconds. Some guys I've seen surveyors just use 3 decimals. That's fine enough for your measurements and so on and so forth. But if you want to show your angles, you got to add that other 0. And besides, when you do really get lucky and do really accurate work, it's nice to see if you can reduce. The whole idea of surveying and running traverses is to try to get perfect. You're always trying to get perfect. You almost never get perfect, but you keep trying and get those numbers, those residuals down as small as possible to zeros. The farther you take your decimals out, the harder that is to do. All right, so now let's figure out how to do that one there. For instance, I was going to show you what cotangent and all that stuff. Now let's just do, for instance, a cotangent. Tangent is the opposite over the adjacent. Let's reverse those. Let's go to 270, enter, 110, divide, 2.5 over. Now we're going to go arctangent on that. Arctangent. And we got 67, 83, 37. That's something you can do with arctangent. You can do that. That's another way to check. We did this with the subtraction of the 180 degrees. We did this going minus 180, minus 80 degrees. That's how we got to that. But now we've just checked it with the cotangent of the tangent. So let's try to figure out the normal way to do it. Now we're looking at this vertex. I'll switch colors up here. Let's go with this color. Let's go with red. We'll circle B. We're using this perspective. This vertex of the angle, versus of the angle. Let's do it first with the tangent. We just did it. We just did it from here. We just did 270 minus, and then we got that. So that's our first check. Now let's solve that angle using the cosine. The adjacent over the hypotenuse. Let's try that. 110, enter. And this is another reason it's nice to store these, because now I'm going to write all these 4 decimals in there. So let me just clear that out. I'm going to write that in 291.5476. And I'm going to store that as 3, and I'm going to write that down. 3. Okay, I'm going to store that as 3. Now also, I've just written 291.5476, and you know, when I showed you on the show, that carried out 20 decimals. So This is going to be accurate up to 10 thousandths, but it's not going to have those other ones to draw on, which isn't going to matter. It really isn't going to matter. But just so you know. Okay, now we're going to do the cosine. We're going to solve this angle using the cosine of these two angles, or two sides. So we're going to go 1, 1, 0, enter. I'm going to go recall. Let's see, what am I recalling? 3. 291, 5476. Now we're going to divide that. 03773. And now we want the arc sine of that. The arc cosine. Oh, these are all from angle A. Okay, we're doing these from angle B now. Oh, let's write that down. B. Now we were looking like cosine of walls. 110 291 5476. Okay, this should be out a little more like this. That's the cosine, so that's what we're looking at there. Okay, so the arc cosine is 67, 83, 37. That's the digital degrees. So put another check. So now let's try, what are we missing? We're missing this. We already did the tangent. Let's do the sine. It would be the opposite over the hypotenuse. So now we've got 270. So the sine is going to be, we're going to go sine is going to be the hypotenuse and the opposite. This is B here. And this is 2915476 and 270. All right, that's the sine. I'll call that sine from B. All right. So the opposite is 270. Enter. See, if I don't write that down, so now to recall 3, divide 0.9261, 0.9261, and that would be arc sine, and 67, 83, 37. 67, 83, 37. Okay. Take a look at that. You can always do screenshots if you want to save these. Later on, we're going to get into formulas, and you're going to definitely want to somehow either take notes, write those formulas down when we do non-right triangles and curves, those types of things. Anyways, but like I say, identifying these components, you might as well write there. From B's perspective, the tangent is this one. B perspective, 110.270. Let me draw that out so it looks right. This is the tangent. That's the opposite over the adjacent from B. Okay. Being able to identify those parts and using the right sign, the right function, is the key to solving right triangles. Once you have that, you can solve them every which way. So tomorrow, we're not going to complete a triangle. We're going to just put elements in and work and then solve them from there. We're going to do different triangles. Then we're going to use the triangles to solve real world problems that you might come into, real world challenges. So you can actually apply them as if you were applying them to real things. So that's about all today. I think I'm somewhat close to a half hour, probably a little bit more. And eventually I'll show you what the instruments look like and all the equipment that we use for surveying. But hopefully if you're a student and you're not a surveyor, at least this stuff will help you. This is just basic trig now. This isn't really survey specific, but we'll do some survey stuff, how we use it surveying, and I think it'll be a lot more, it'll create a lot more interest for even non-surveyors. Surveyors just need to know it. They need to know this stuff. They need to know what your data collector is doing. What's going on in there? How is it making these measurements? How's it doing it? How do I check it with this baby? How do I back in an elevation? How do I transfer an elevation? How do I how do I create a coordinate? How is the data collector creating these coordinates? How's it doing it? So, and they're doing it seconds, every few seconds, or sometimes faster than that. All right, that's it. Thank you. And tomorrow we will carry on. This was lesson 2, and I'm Lee, and see you tomorrow.